Hi, and thank you very much for your interest in our research. My name is Vojta Smekal, and I'm going to talk you through our study, Influence of Haptic Feedback on Perception of Threat and Peripersonal Space in Social VR. This is a study I conducted with my collaborators, Jeanne Hecquard, Sophie Kühne, Nicole Occidental, Anatole, Lécuyer, Marc, Macé, and Beatrice de Gelder. To get started, let's talk through some of the terms that we use in our title. First off, peripersonal space. Now, peripersonal space is defined as a region surrounding one's individual body where certain stimuli and actions can have greater behavioral relevance. This is essentially quite a complicated way of defining your personal space bubble, or a region around you where if something happens, this draws your attention more than if that same action happens further away from you. For instance, if a ball flies right past your head, that will probably be more interesting to you and draw your attention more than if that same ball is thrown between two people 20 meters away. And what research has shown is that the size of this peripersonal space is not static. It's not set in stone and can very much change due to various factors. For instance, the emotion of another person you observe can affect this personal space. If you see someone looking very angry and threatening walking towards you, you are more likely to feel uncomfortable sooner, you are more likely to take this into account and pay attention to it sooner than if someone who is very neutral or very peaceful is walking towards you. So this is the idea that this peripersonal space, your personal space bubble, enlarges or shrinks depending on the circumstances and the context around you. And what we were interested in doing in this study was to see if we could also affect the size of this peripersonal space through haptic stimulation. In the past, haptic stimulation has been found to induce both positive and negative feelings in people, and research has also shown that it can affect your perception of distances and space. We were then interested to see if it could also affect the perception of not just a specific physical distance, but also a more subjective, intuitive distance that you feel, your personal space boundary. This then led us to have 3 specific questions and hypotheses for our study. Firstly, we wanted to replicate the previous findings and show that emotion of other people you interact with can indeed affect your peripersonal space size. Additionally, we then wanted to show if haptic feedback could affect your peripersonal space. As a sub-goal to this, we wanted to see if there could be variability and gradation to this. If we vary how intense the haptic stimulation is, can we also affect how much the peripersonal space shrinks or grows? Or is it instead a binary effect of haptic stimulation, where the presence or absence simply determines the effect on peripersonal space size, or perhaps there's no effect at all? To achieve this, we used a virtual reality task where a person was in a dark alley environment and was approached by an avatar. This avatar could approach in one of 2 ways. Either they would approach as the so-called neutral avatar, in which case a person walks towards you, arms to the side, relatively neutral, or they could approach as the so-called angry avatar, in which case the arms are raised as if the person is about to punch you, and there's an additional arm raised just before they do reach you. While the participants were in the virtual reality task, they were also fitted with a compression belt. The belt consisted of an elastic band wrapped around the torso of the participant and a servo motor that tightened during each trial, as you can see demonstrated in the GIF on the right. Here is a visualization of what occurred during each trial. So at the beginning of a trial, the belt would sit comfortably around the participant's torso without applying any pressure, and they would observe a static avatar for 1 second. The avatar would appear in front of them for this 1 second, but not move. After the 1 second had passed, the avatar would begin to move towards the participant at a constant speed for 6.5 seconds. And during this dynamic phase of the avatar moving, the belt also began to tighten around the participant's torso. As you can see from the 3 colored lines in the chart, this tightening could happen at one of 3 different speeds, which would lead to varying intensities of pressure applied by the end of the trial. For each trial, the participants were asked to press a button when they felt uncomfortable. This button press had a 50% chance of stopping the avatar from approaching any further. On the remaining 50% of trials, pressing the button had no effect. We used this button press as a measure of the peripersonal space. The sooner the person pressed the button, then we argued this meant that their peripersonal space was larger, as they were more uncomfortable by the approaching avatar at a greater distance further away from them. This chart visualizes a summary of all the different factors we had in our experimental design. On the top, you can see the 3 different speeds of the belt, as I mentioned, when the belt was active and tightening. On the right, the trials were split into 2 halves, half of the trials where the belt did tighten, and half of the trials where the belt did not tighten. And then on the left, you can see the 2 different emotions of the avatar, either angry or neutral. Each participant completed 240 trials, and you can see in this diagram how many trials were in each category and condition based on the numbers in the boxes. And so to our results. Firstly, we very nicely replicated that indeed the angry avatar led to earlier responses than the neutral avatar. So as you can see here, the distance between the participants and the avatar when the participants pressed the button was greater when the avatar was angry than when it was neutral. This was true both when the belt was active, the diagram on the left, or when it was not active, the chart on the right. Nicely confirming our second hypothesis, we also showed that when the belt was active, this led to an earlier response than when the belt was not active. When the belt was tightening around the participants' torsos, they were likely to press the button sooner, and when the avatar was further away from them than when the belt was not tightening. Here, you can see a visualization of the interaction between these two effects, the avatar emotion and the haptic stimulation. What we found is that actually the belt had a greater effect when the avatar was neutral than when it was angry. We interpreted this finding as evidence for a Bayesian process of evaluating a situation as threatening. When you have a strong visual cue that something is threatening, such as a clearly angry, threatening avatar, you do not pay so much attention to other cues. The nature of the situation is very clear. However, when the visual cue is more ambiguous, such as the avatar being neutral, you then pay attention to other cues in the environment, such as the haptic stimulation, to assess whether the context is threatening to you. Hence, a stronger effect of the haptic stimulation when the avatar is neutral. Additionally, confirming our third hypothesis, we also found that the intensity of the belt tightening increased, then so did the peripersonal space size. When the speed of the motor was highest, the plot on the right, then the pressure was highest. This was also when the participants pressed the button the earliest. We also had participants complete several questionnaires after the VR task, including questions about various feelings the participants had about the whole experience, and specifically how their experience was different when the belt tightened and when the belt did not tighten. What you see here are the results for how the participants felt when the belt was tightening. And what you see is that the participants felt more anxious, more present in the scene, more threatened, that their personal space was breached faster, and they felt less relaxed, less disconnected, and less safe when the belt was tightening, suggesting that the haptic stimulation also significantly increased their immersion in the scenario, and it very significantly affected their subjective perception of the experiment. So to summarize all of our findings, we found that both the emotion of the agent, or the avatar, and the haptic stimulation significantly affected participants' threat perception and peripersonal space size. An angry avatar, with the belt tightening around the participant's torso, led to the largest size of peripersonal space and the earliest response. Additionally, we also found that this effect of the haptic stimulation wasn't a binary yes or no effect, but quite to the contrary, having greater haptic stimulation led to a greater effect on peripersonal space than less intense stimulation. We also found that the haptic stimulation significantly affected participants' subjective experience of the VR environment, significantly increasing their immersion and the realness of the experience. We believe that our results strongly support a clear effect of haptic stimulation on people's perception of interpersonal interactions, specifically in the context of understanding social threat. Thank you very much for your attention, and we hope to see you at the conference.